At this point, you might be wondering, why use matrices? What's the benefit in this course? Matrices are actually very prominently used in engineering, in physics, computer codes, statistics, and many more. Okay, because it's a great way to store data. This data can be either numbers, some functions such as polynomials, or any mathematical object for that matter. And matrices can represent a mathematical model much simply. Now let's consider an example where we have a system of equations. Let's say our first equation is 2x plus 3y minus z is equal to 4. Second one is x minus 2y plus 7z is equal to 2. And the third one, let's call it 4x plus y minus 3z is equal to 0. Okay, so here we have three equations and three unknowns. Right, our unknowns are x, y, and z. So this set of systems, we know how to solve it by hand. But what if wanted to automate the process? And what if we had, let's say, 600 equations and 600 unknowns? And you can see how that process can be very cumbersome. To solve for 600 unknowns using 600 equations. At this point, we would rather have the ability to code this up in a programming language such as MATLAB and find a solution using an algorithm. So in order to do that, let's take equation 1. Okay, reconsider our equation. 2x plus 3y minus z is equal to 4. Okay, you can say that my left hand side is a matrix of 1 by 1 dimension, and the right hand side is a matrix of 1 by 1 dimension. Okay, so I can then write it in a matrix term. Okay, consider our LHS again. which is 2x plus 3y minus z. I can also write them as a multiplication of a row vector and a column vector, where my row vector would be 2, 3, minus 1, which are simply the coefficients of our unknowns. And the column vector would be the unknowns x, y, and z. As you can see, the size of this row vector is 1 by 3, and the size of this column vector is 3 by 1. Hence, the resulting matrix will be of dimension 1 by 1, which agrees with our previous statement. Okay. Similarly, we can derive such formulation for the rest of the equations as well. Now, what if we were to take 3 equations and write it in terms of a column vector? Okay. So then we'll have 2x plus 3y minus z, x minus 2y plus 7z, and third component 4x plus y minus 3z. And then our right hand side would be the column vector 4, 2, 0. And this is based from the fact that if a matrix A is equal to a matrix B, if and only if each and every component of a matrix A is equal to each and every component of matrix B. And we can see that from this relation, our first component of the left hand side, 2x plus 3y minus z, is equal to 4. Second component is x minus 2y plus 7z is equal to 2. And third component, 4x plus y minus 3z is equal to 0. And we can return to our initial system of equations. Okay. Now, similarly to what we did here, where we took our 1 cross 1 matrix and decomposed into a row vector and a column vector, we can take it component by component and decompose them into a row vector and a column vector. Okay, so we can alternatively write this as row vectors of coefficients for each equations, 2, 3, minus 1. This is the first row vector. Second row vector would be 1, minus 2, 7. And the third one is 4, 1, minus 3. That is multiplied with the column vector of the unknowns x, y, and z, which is equal to 4, 2, 0, which is the column vector. And as you can see, the size of this matrix is 3 by 3. Unknown is 3 by 1. And the resulting vector is also 3 by 1. And this makes sense if you see, if you multiply the matrix, which is consist of coefficients. So we'll call it a coefficient matrix. Take the first row and multiply it with our unknown vector, and you will end up with a 2x plus 3y minus z. And similarly for the rest of the rows as well. Okay, so what we did here, we turned our system of equations into a matrix form. Once we have a matrix form, you can see that we have two matrices, coefficient matrix and our right hand side matrix, right? These two matrices are simply just the numbers. And once we have numbers, we can code it into a computer program. Okay. Let's write this system of equation in a matrix form, where C is our coefficient matrix, 3 cross 3. X is our unknown, 3 by 1 is equal to our right hand side matrix. So then, in order to solve for our unknowns, X, we can simply take an inverse and multiply with B. Okay,